Hi everybody. So what we got here is the data from our equal volumes of gases lab, and what we're going to do is go through the calculations and try to figure out what all this stuff means. Okay. So I collected data for oxygen and I collected data for nitrogen, and we figured out we got the mass of the gases with the flask, the mass of the flask, which we vacuumed all the gas out, so just the mass of the flask, and then we found out the volume of that, the volume of the gas there. So first thing we're going to do is we're going to find the mass of the gases that we use. So next to this, I'm going to put O2. So we're going to take 189.06, which is this one, minus 188.80 grams. And that's going to equal about 0.26 grams of O2. Similarly for nitrogen, we have 174.42 minus 174.12 grams, and that's going to equal about 0.3 grams of nitrogen. So real small amounts of real small masses of gases, which we expect. Gases don't weigh a whole lot. And the next thing we're going to do is going to calculate the moles. So this is the moles of O2, moles of N2. So if we have 0.26 grams of O2, we're going to figure out how many moles of O2. And if you remember our stoichiometry, we have to convert from grams into moles using molar mass, and for oxygen it's 32 grams. Now, since this value is going to be a real small one, we're going to carry out to a bunch of decimal places here, even beyond any kind of, I didn't really keep track of sig figs up there. I guess I did actually. And we'll do the same thing for nitrogen. So we're going to take our 0.3 grams of N2, and we're going to convert 1 mole of N2 into using the molar mass, 28 grams, and we're going to get 0.0107. Oh, not on screen anymore. Here we go. 0.0107 moles of N2. Okay. So why do we do this? Well, we're actually going to try to figure something out that that Avogadro, amongst giving us our Avogadro's number of 6.02 times 10 to the 23rd in terms of atoms or molecules. What we want to figure out is what's the relationship between moles if you have equal volumes. Okay. Now, when we went up here, so what we figured out is that we have more moles of N2 than we do O2. Now, that's kind of to be expected if we look up. Well, this is the volume for nitrogen, and if you have more volume, you should probably have more moles, so it's not too much of a shock. So what we're going to do is we're going to say, if we had an equal volume of oxygen, would we have the same number of moles? So here's what we're going to do. So we're going to take, in this space here, we're going to say we had 0.00813 moles of O2 in 168 milliliters of space. Now, we're going to say if we had 232 milliliters, like nitrogen, how many moles of O2 would we have? So if we had the same space there, would we have a similar number of moles? When you solve for X here, we get 0.0112 moles of O2. All right. So we're going to put over here on the right-hand side 0.0112 moles of O2, and we're also going to take this value for nitrogen and bring it down, 0.0107 moles of N2. So this is our number of moles. This is our moles of nitrogen, and this is our adjusted amount of oxygen, to say that if we did have the same volume, would we have the same number of moles? And if if you look at our numbers, these numbers are really, really close to each other. In fact, they ought to be the same. Because what Avogadro said is that if you have an equal volume of gas, you will have an equal number of moles of that gas. And it doesn't matter what gas it is. It has to do with just the volume of it. Because gases, as we remember, gases have a lot of space between the particles. And because of that, it doesn't matter the size of the particle. All right? Even though the oxygen would be slightly larger than the nitrogen, there's so much space in between that you would have the same number of moles in the same volume, okay, as long as your temperature and pressure would be equal. All right? Hope that helps clarify the calculations on this lab, and keep reading about Avogadro. That's good stuff.